Okay, welcome back to part 2 of 5.1. Hopefully you got some time to look at those graphs that I gave you. Hopefully you can kind of make sense of some of it at least. If you're still a little shaky, that's okay. Hopefully by the end of this video, I've got everything kind of laid out nicely for you. So in the last video, I didn't get through much. I got through our sine and cosine waves. I showed you these two, right? I went over the definition of period and I went over the definition of amplitude. We looked at domain and range with our graphs and all of that. So today, or I guess in this next video, what you're going to look at is what happens to the amplitude and the period when we add values of A and values of B. Okay, we've added A and B values before, right? We've done that in chapter 1 or 2 and 3 and a whole bunch of them, right? It was simply just a way to transform our graphs. So we can do that to our sine and cosine graphs as well. So what I did here in this slide is I sketched 4 graphs for you to the best of my ability with my little stylus thing here and my small screen. So on this, I guess I should start explaining. This black graph, okay, y equals sine x, is simply the one in black. Okay, so right there. I'm not going to trace over the whole thing because I'll probably screw it up. That's literally the exact same graph as this, right? I just kind of, shrunk it a little to put it on here. Then in terms of different values of A, so in this pink graph, A is 3. You guys see that? See, the A always comes in front. So when A is 3, all that means is that your highest peak is now 3 and your lowest peak is now -3. So I put my highest peak at 3 and I put my lowest peak at -3 and then I drew my graph. Okay, here 0.5 sine x is in red. That one's the crappiest one out of them all. But all that means is the highest peak is at 0.5, lowest peak is at -0.5. Okay, which you should be able to see. Highest is there, lowest is there. Okay, and then everything else stays the same. When you have a negative A value, it's reflected in the x-axis. Okay, you guys should know that. So that's honestly no new information there. But because it's -2, that's where it starts. So that's where the lowest value is, I guess. So lowest value right there at -2, highest value up here at 2. Okay, and do you see how it's reflected in that x-axis? It's not like this anymore. Now it's like this. Okay, so honestly, I wouldn't have even had to draw them for you, but I could have just put those in Desmos, which I did in the next one, just to show you so you can see how Desmos is lovely. So basically what I want to show you is how to calculate the amplitude of each of these. Okay, now you can remember from my last video, your max minus your min divided by 2. Right? So I could do that if I wanted for each, like all 4 of these graphs, right? But an easy way to figure out amplitude is it's the absolute value of A. So the absolute value of A equals amplitude. So in this first one, in the black one, right, the value of A is actually 1, right? So that means amplitude 1. Here, A was 3. Absolute value of 3 is 3. So that's what the amplitude is. Here, 0.5. Absolute value of 0.5 is 0.5. That's the amplitude. Here, -2. So absolute value of -2 is 2. That means that's your amplitude. Okay, so it's as easy as that. You just need to know this. Okay, important. Okay, so anytime you're looking for amplitude, just go absolute value of A. You don't even have to draw it. Okay, then it says compare the period length, domain, and range. So with all of these, the period length is the same, right? It's 2 pi. So it starts wherever it goes, and then it stops at 2 pi, and that's one kind of rotation. Domain is XER, right? Domain isn't changing. Range for each of these is going to change, right? Because the black graph, right, to start, that's between 1 and -1. The pink graph is between 3 and -3. The red graph is between 0.5 and -0.5. And the green graph is between 2 and -2. So that's how your range will change. I'm not going to write those all out for you, but that's just what you have to notice. Okay? So that is your A values. Good? Hopefully. Okay, if you can remember amplitude is the absolute value of A, you're going to be just fine. All right? So for this next slide, it looks at B values. Okay, so B values affect your X. But for these ones, I actually just graphed them in Desmos because it's nicer to see. So when we're looking at B, okay, like we are here, the one thing you need to notice is that B affects the period of your function. Okay, and in order to find the period of anything, you just go 2 pi divided by B. Or if you're in degrees, you just go 360 divided by B. All right, so let's just look at this one. I'm not even going to sketch it right now, but what is B? If I looked there, B is 4. Okay, don't worry about flipping B or anything right now. You don't actually have to do that for sine and cosine. Okay, so B is equal to 4. Now, if I were to say, what's the period of that? And you're not even graphing anything. I'm just saying, what's the period? Well, see how we're in degrees? You're just going to go 360 divided by 4. And when you do that, you can get your period. Okay, which would be 90 degrees. So let's just check to see if that was right. So what I did is I graphed y equals sine 4x in Desmos. Because this is in degrees, I should have my Desmos in degrees. Okay, so right now I don't. It's actually in radians. So I will fix this for you. Okay, so sine 4x is there. Let's go in here. Now I'm in radians, but I want to be in degrees. And let's put my step as, I don't know, 90. Okay, so I'm just going to do some pinching. There. All right, so that is the graph of sine 4x. Okay, now sine 4x, if you just graphed that, you forgot that, okay, to find the period, I have to go to 2 pi or 360 divided by 4. You could just look here. How often does it take till it repeats? So it goes up, down, and back up again, right? So what value is right there? 90 degrees. Is that what we got? Yes. Okay. So you could look at the graph. You can use the 2 pi divided by b or 360 divided by b, whatever you want to use, but just make sure you know what you're doing. Okay. So that is that. I think that's all we had to do. Okay. So there's that. There's that. I think I said that 12 times already. This is just for reference to show you what the actual sine graph looks like. So in green, okay, you can see the sine graph. Okay, hopefully, anyways. And then because we're just looking at 0 to 360, I'll just go like that. So it repeats once, just the regular sine graph, but with the orange graph or the red graph, notice how it goes down and up, down and up, down and up, down and up. Okay, all the way to 360. So that's how they compare. What else do I want to... Oh, we got to go over this cosine graph. So this cosine graph is another example. And here it just says y equals cos 1/2 x for 0 to 2 pi. So that means that this is in radians, right? Other one was in degrees. So we just got to sketch it. Let's just, what's b equal to? B is equal to 1/2. And in order to figure out what the period is, you go 2 pi divided by b, which is 1/2. Now 2 divided by 1/2 is 4. And then you have your pi at the end. So 4 pi. So let's see if that's right. Okay. So we are going to go back to here. I'm going to exit off these sine ones. There is my cosine. And remember, I am in radians. So let's put radians and let's put pi over 2. Okay. I usually like looking at radians better. It just seems the graphs are nicer. Okay. So there you go. That is cos 1/2 x. Now, we said that the period, going back here, was 4 pi. Oh, I keep clicking the wrong one. 4 pi. So let's see if we're right. So period starts here, goes down, and by the time it goes back up, that value right there, 4 pi. Okay, so we were right. Good. I guess to compare it to the cosine, just the regular graph, this is what the regular cosine looks like. Okay, good. So that is just comparing the two. Now it says putting it all together. So this is just when you have A's and B's in the same one. So you are going to go straight to Desmos and you are just going to graph this. Okay, y equals -3 cos 2x. Y equals -3 cos 2x. And did it tell us in degrees? Oops, sorry. Degrees or radians? It did not. Okay, so you can pick if you would like to do degrees or radians. It didn't say, so whatever you would like. I have Desmos and radians right now, so let's just use that. Okay. So looking at this, we need to figure out all of our information. Just gonna scrunch it a little. There, that looks much nicer. So first thing we got to look at is amplitude. Okay, amplitude is always the absolute value of A. So absolute value of A here, what's A? A equals -3. So the absolute value of that is 3. Good. Period. We're going to deal with radians. Okay. I don't know if you can see that. So period, what's B? Period always deals with B. B equals 2. So in order to figure out the period, you always go 2 pi divided by B, which is 2, which is just pi. Our maximum value we need to figure out. We need to figure out our minimum value, x-intercepts, y-intercepts, domain and range. So maximum value here, maximum value is right there. So 3, right? Minimum value, -3. So max, we can write 3. Min, we can write -3. X-intercepts is just where it crosses the x-axis. So it crosses at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. So you should be able to see a little bit of a pattern there, right? So it's pi over 4, basically pi over 4 plus so clicking these again. Right, that repeats forever. So in order to get from pi over 4 to the next one, which was 3 pi over 4. What did I do? I added 2 pi over 4, right? And then I add 2 pi over 4 again. And then I add 2 pi over 4 again. And I do this for forever, right? Now 2 pi over 4 is the same thing as what? Can I reduce that? Yes. That's the same thing as pi over 2. Okay? So what I'm actually doing is I'm adding multiples of pi over 2 to pi over 4. So I know this is a little bit out there, but instead of writing this ... and forever, you will never see that in a textbook, okay? You would see pi over 4 plus, now we're adding multiples of pi over 2, right? So we're going to add pi over 2 and multiples of it. So n is what we label that as. Okay? Now n is just a number, so like that could be 1, 2, 3, 4, and then that just increases this. Okay? So that's how you would write your x-intercepts. Your y-intercept would be where it crosses the y-axis. So at -3. Domain, what could my domain be? Hopefully you said XER. Okay, and then the range, you always look at the highest and the lowest. So my highest is 3, my lowest is -3. So that means y is between 3 and -3. Okay, so that's my range. That would be my domain. Okay, so that's putting it all together, like it says here. I'm not going to rewrite all that there. We just went through it. So let's see. Last slide. It says key concepts. The 5 key points of sine and cosine. Those are the ones that I plotted. I guess you should know this. This is really the most important thing out of it all. Okay? Amplitude, maximum min divided by 2. Or you can just go absolute value of A is amplitude. Okay? And then your period length is just 2 pi divided by B. Oops. Or if you are in degree mode, you should have 360 divided by B. Okay? So just, you got to check what your question's in, whether it's degrees or radians. Okay? So that is going to wrap up 5.1. And that's going to wrap up the week. So I don't know if you noticed on my Google Classroom, I said no class on the Friday. I think it's the 15th. So like if we were at school, you wouldn't have school on Friday. So I'm just planning 4 days worth of work for you. So make sure you take a day off. Give your brain a break, unless you've taken 7 days off and then you don't get that break, okay? So here's a textbook assignment that I want you to do to practice this. It's on page 233. And let's do number 4 to 9, ACE. Okay, so hopefully that should give you some practice. It's all going to deal with amplitude and period length, okay? Use Desmos if you need to. If you're having trouble, always resort to looking at this this lovely little wrench here, and then check if you're in degrees or radians, okay? That's usually like the first step, okay? And then if you're still having trouble, just let me know. All right? Okay, hope you guys have a good weekend. And let me know if you have any questions, okay?